However, what do we do when there is multiple, when there is an answer of A, where we've got a coefficient greater than 1? Well, the numbers that we choose would, therefore, we will need some sort of factor to go in there. So if you can imagine, and I'll get some highlighters out, if we can consider M is a factor of A, so let's just say it's some factor of the first number, and then we've got N is a factor of D, then what we do is we try to substitute N over M into the equation to see if this will plop out a very lovely factor. Spoiler alert, this is going to be awful. And this was when we have some horrendous fractiony type ones. This is called the rational root theorem. So the idea that if I was to put this together, that I can find a factor involving a fraction. So let's go and have a look at our numbers here. So we've got 5 here. So I'm going to do is my factors of 5, of -5 here. So it could be 1 or -1 or 5 or -5. That's fairly straightforward, which is wonderful. We've got a 3 at the front there. So factors of 3. We've got 1, -1 or 3 or -3. So trying to choose numbers that would be able to fit in here is a little bit challenging. I would not expect you to be able to get the factor instantly unless you're some kind of clever clogs. Then great, clever away. I will say this though. I reckon that the denominator will probably, if I was to substitute number, will probably end up having to be 3 to knock out this 3 here. I reckon, but that's just me having a very loud guess. So what I'm going to do here is I'm going to just try what I would normally do, my go-to. We may as well try, we've got a lot of positives here, so I would try some negatives to cancel some things out. So I'm going to go -1 over 1. So I've taken the factor of -1 from the factors of 5, and I've taken the factor of 1 from the factors of 3, which of course would be equal to -1 here. And so this would be 3 -1 cubed plus 8 -1 squared plus 2 -1 minus 5. So this is going to be equal to some horrendous value here. Oh, it's not too bad. That'll be -3. That'll be plus 8. That'll be minus 2 minus 5. And that gets us equal to -3 plus 8 minus 2 minus 5 is 4. So x plus 1 is not a factor. Okay, so you would then take in turns of working out for each one that you would need to do. I'm going to try using a negative number. Again, I'm going to use my instincts here that it would be a something divided by 3. I reckon we might have to use this fraction here. So I'm just going to try and do -5 over and 3. Might not work. We'll try it. We'll give it a go. It's not going to be a pleasant series of multiplications, but that's why we do methods, is to exercise our brains. Not everything should be clicked into place. It's always very good to get our fractions on. So here we go. Now, -5 cubed, for our fun fact fans, we'll make that -125. 3 cubed is 27, but we've got this 3 out here to cancel out, so that's going to be -125. Instead of over 27, that's going to be over 9. And then we've got plus, now -5 squared is going to make that a positive 25. 25 times 8 is going to make that 200. 3 squared is being 9, so that's 200, and that's going to be 9. 2 times negative 5 is going to make that negative 10 over 3 minus 5. I would suggest that it would be very worthwhile to try to get everything in the same denominator. So I'm going to go with 9s for now. So this is 200 take away 125 makes that 75 over 9. We'll need to times this friends by 3. So that's going to make that 30. So all I've done there is I've just times that by 3. I've times that by 3 to get that as the same denominator of 5. Negative 5 or minus 5 is the same as saying negative 5 over 1. So I would need to times this by 9, times that by 9. And that's going to be minus 45 over 9. And blow me down, 75 over 9 minus 75 over 9 gets us 0. So therefore, x plus 5 over 3 is a factor. Now at this stage, I would highly recommend, so you'll see here we've got x plus 5/3 is a factor, which is wonderful. Now we're about to do some long division. Long division with fractions in it is awful. So I would highly recommend doing some jiggery-pokery. And the jiggery-pokery looks like this. We can actually rewrite this. If you ever get a fraction in here, it actually can be rewritten as getting that 3 off the denominator. It can be rewritten like this. How do I know that? Well, let it equal 0. So let equal 0 and let 3x plus 5 equals 0. So this will becomes x plus 5 over 3 over 0. X is equal to negative 5/3. 3x plus 5 equals 0. 3x is equal to negative 5. X is equal to negative 5 over 3. There we go. I managed to prove here that both of these would end up having the same answer. So there you go. That is why I would go about changing it. So doing the long division part is not going to be horrendous. So we're going to do a long division over here. Fun fact, when I was preparing this video, this page would have been much longer because I went through every combination and I can tell you, it takes some time. So 3x cubed divided by 3x, well, that's just going to be an x squared. And then x squared times by 3x is 3x cubed. X squared times by 5 is positive 5x squared. Minus these. 3x cubed, take away 3x cubed is 0. Positive 8x squared, take away 5x squared is going to be 3x squared. We're going to plus 2x here. Bring that down. And then we're going to go and divide 3x squared divided by 3x. Well, that just leaves a lovely bit of x left over. X times by 3x gets me 3x squared. X times by 5 gets me 5x. And then I go into minus these friends. So 2x take away 5x is negative 3x. And we get that minus 5. Minus 5. Negative 3x divided by 3x is negative 1. Negative 1 times 3x is negative 3x. Negative 1 times 5 is negative 5. And divided by 0. So my answer is 3x plus 5 x squared plus x minus 1. Now, this is where you'd be wondering, all right, can I factorize this other one here? Can I go and turn this into something else, into a simpler form? Well, it doesn't really factorize very nicely here. And I think you'll find that no matter what you do, I mean, you could, actually, yes, you could factorize it. It's going to be awful, though. So we'll have to complete the square of this one. So what I'm going to do is I'm going to just complete the square. And then this will become x plus a half. minus a quarter minus 4 on 4. I've just turned that -1 to -4 on 4. So that becomes -3. Oh no, it doesn't. It becomes -5 on 4. And so we can use our understanding that this would become 2 brackets. So this would mean that the first one would be x plus a half, x plus a half, plus, and then minus square root of 5 over 2, square root of 5 over 2. And so our fully factorized form would in fact be this lovely answer at the end. There we go. We have now fully factorized. That means it has 3 x-intercepts, and we've got some horrible, horrible surds to deal with. Well, I'm sure the surds don't think they're horrible. I think that they are quite happy as they are. So there we go. We have fully factorized it accordingly. So we've also got some cubic factor patterns, and if you've got the difference of perfect cubes, you'll end up being like this. You don't end up having to do this terribly often, but it's useful to know. There might be some questions where it involves these kinds of answers. For the next ones here, where we're needing to find a pronumeral, just kind of like the ones we were doing before, this would be a great example of being able to substitute, rather than, you don't need to do long division when there's letters involved. So if I know that it can be divided by, it's exactly divisible by the second, that means if I was to substitute, I'm just going to let p of x equals to x cubed minus 4x squared plus x plus m. If I substitute 3, it should equal to 0. So that's what I'm going to do. 3 cubed minus 4 times 3 squared plus 3 plus m is equal to 0. So that's going to get us a very lovely, satisfying answer of 27 minus 36 plus 3 plus m equals 0. Negative 6 plus m equals 0. M is equal to 6. There we go. Splendid. So again, that's very similar to the other ones that we were doing a little bit earlier. And then we've got these small atrocities here. Again, you would need to go and use the factors here. Now, notice in this first one for C, I'm just going to look at C here. I've got a 6, I've got a 6, I've got a 13, and a 13. My gut instinct says that if I do, let's try P of 1. Let's see if I can factorize this by doing P of 1. Because if I was to do that, so I got 6 minus 13 plus 13 minus 6. That's definitely equal to 0. So we can go and factorize this accordingly. So we'll do our long division. And we know that x minus 1 is a factor. So 6x cubed divided by x gets me 6x squared. 6x squared times by x is 6x cubed. 6x squared times by negative 1 gets me negative 6x squared. Minus these. Those will cost me 6x cubed. Take away 6x cubed is 0. Negative 13x squared minus 6x squared. So that's going to be, we're going to need to do a plus here. Gets me negative 7x squared. And yeah, so then what we'll do is we'll bring that 13x down. And then what we're going to have here is we're going to go and go, I've written that right, negative 7x squared divided by x is going to make that negative 7x. Negative 7x times by x is going to make that negative 7x squared. Negative 7x times by negative 1 is positive 7x. So 13 minus 7 is going to make that 6x minus 6. 6x divided by x is equal to 6. 6 times by x is 6x. 6 times by -1 is -6. We'll minus those and I get a 0. So my answer is equal to x minus 1, 6x squared minus 7x plus 6. Now, can you factorize this? I'm afraid you can't. For this one here, you can try all you like, but that is definitely going to be above the x-axis. So there's nothing that you can do to factorize that. However, I don't believe me, so let's go and just triple check with Kaz calculator here. It's always worthwhile to check, because the other reason why I'm not doing this particular bit by hand is that it's just awful. It's just trying to factorize with a non-monic quadratic. I mean, I can do it, but can it? No. So it cannot be factorized. It just stays as is. So that's going to stay as it is. And similarly, even if we try to solve, there's no solution because it's well above the x-axis. So there we go. So that's fine. For part G, as a reminder, when we do our division for part G, we'll need to make sure that we'll include a 0x squared because we don't have any x squareds here. My guess here for this one would be to do for part G, we will try P of 2 because that might knock something out, I reckon. So 4 times 2 cubed plus 3 times 2 minus 38. Ooh, 38. So now the reason why I've chosen 2 is that if I was to put a factor here, that would be the same as doing, because 38 it can have a factor of 2, 4 can have a factor of 1, so it'd be 2 over 1. So 4 times 8 gets me 32, plus 5 minus 38, huzzah, 38 take away 38 gets me 0. So we're going to go and divide accordingly. This will be x minus 2. So I'm just write x minus 2 is a factor. So 4x cubed divided by x gives me 4x squared. 4x squared times by x is going to get that 4x cubed. 4x times by -2 is going to be negative 8x squared. Oh, and silly duff of me, I have completely forgotten to put my 0x squared in there. There we go. Easy fix. So 4x cubed, take away 4x cubed is going to get that equal to 0. 0x squared, take away minus 8x squared. That's going to make that a lovely positive 8x squared. 8x squared divided by x is going to be 8x. And then we're going to multiply that. 8x times by x is 8x squared. 8x times by -2 is negative 16x. 8x squared, take away 8x squared is going to be 0. 3x minus 16x is going to be 19x minus 38. And we'll do another division. 19x divided by x is positive 19. Okay, so 19 times x is going to make that equal to 19x. 19 times by -2 is negative 38. Huzzah. We have got our value. So our answer here and again, this is a positive quadratic. It's been moved up of the x-axis, so that will not be able to factorize. But again, don't trust me. Let's go and double check on our lovely CAS calculator here. This CAS calculator is brought to you by ClassPad. ClassPad, the sensible alternative. So 4x squared plus 8x plus 19. Yep. And even if I try to solve, the answer equals 0. There's no solution. So that is definitely, as factorize, is that friend is going to go.